सो हम क्या देखेंगे, मैथ्स का देखेंगे। तो मैथ्स के लिए पहले आता है काउंट डिजिट, मतलब वी हैव डिजिट जैसे 1 2 3 4, और इसमें क्या है 2 और 1 से नंबर डिविजिबल है, तो उसमें बताना है कि कितने नंबर ऑफ हैं जो कि खुद से इस डिजिट में डिविजिबल हैं। तो इसके लिए क्या करेंगे, देखो वाइल एन इज ग्रेटर दैन जीरो, जब तक एन ग्रेटर दैन जीरो है तो क्या करो, इफ एन मॉडलो 10, मतलब लास्ट डिजिट क्या है, अगर डिविजिबल है एन से, तो क्या कर दो, काउंट इंक्रीमेंट कर दो +1, और काउंट +1 कर दो, और फिर इसके बाद क्या कर दो, काउंट +1 कर दो, और फिर लास्ट डिजिट को हटा दो। फॉर द रिमूविंग द लास्ट डिजिट व्हाट वी डू, n डिवाइडेड बाई इक्वल टू 10, तो n इक्वल टू n डिवाइडेड बाई 10, तो इससे लास्ट डिजिट हट जाएगी, तो मतलब ये हो जाएगा। और लास्ट में रिटर्न करते हुए काउंट, तो इट इज डिस्क्राइब कि हाउ मेनी digit are in this number are present which is divisible to itself. Second is the reverse the number, reverse the number, तो इसके लिए लिखेंगे while n is greater than 0, जब नंबर n is greater than 0 है, and reverse is equal to reverse into 10 plus last digit, last digit for last digit what we do, n modulo 10 is for the last digit, and n divided by equal to 10, while loop is closed, and return return and return reverse, you get a reverse number. Or third one is a palindrome. A palindrome, for the palindrome, what we do, while n is in the previous question what we do, n is greater than n is not equal to 0, because we both number, for example 1 2 3, we want to reverse it, -1 -1 to 3 is want to reverse it -3 to 1, but in this case of the palindrome, -1 to 3 is not equal to -3 to 1, so that's why while n is greater than 0, reverse equal to reverse into 10 plus last digit, for last digit and modulo 10, and remove the last digit, and divided by 10, and equal to n divided by 10, and close bracket. If reverse equal to number, तो इक्वल टू ये रिटर्न कर देंगे, बिकॉज दिस इज द बुलियन, दिस इज बुलियन कंपैरिजन, तो ये रिटर्न दिस वैल्यू इज रिटर्न, तो रिटर्न दिस, ठीक। तो दिस इज फॉर द चेकिंग द palindrome. थर्ड वन इज greatest common divisible या high factor. तो for the optimal solution, they have a three ways to solve it. First one, कि for one to both numbers के maximum में, मतलब we have n2 and n1 n2, तो from 1 to n max of the n1 or n2, and I plus plus, if I is greater, I f n1 modulo I is equal to 0, and n2 modulo I equal to 0, then GCD is this number restore index I, and at the last return this. First way, second way is from the reverse, starting variable from I is max of the n1 and 2, I is greater than 0, I minus minus, if n1 modulo I is equal to 0, and 2 modulo I is and modulo is equal to 0, return equal to 0, to return what is return, uh, return index I, we get a initial phase of the greatest common divisible of n. Here is the second way. Third is the optimal way, which I remember, while a is greater than 0 and b is greater than 0. If a is while loop can inside the while loop, if a is greater than b, then a equal to a modulo b, else b equal to b modulo a. Yeah, else and while loop is closed. If at the place of reader, if a equal to if a is greater than 0, return b, or else if if a is greater than 0, then return a, else not, return direct, uh, return direct what b, b, return b. So this way we can find the greatest common factor or highest common factor for the LCM. N1 into N2 divided by greatest common factor. This is a LCM for the LCM Armstrong number. Armstrong number, first count the digit and power to all digit, and if the number get is equal to n, then they is called as the Armstrong number, or otherwise they are not called as the Armstrong number. So Armstrong number, first we count digit. So count for the counting digit, if while n is greater than 0, if digit is a variable, initializes the while n equal to 0, and digit divided by digit plus plus और क्लोज, ये कहते देगा टोटल नंबर ऑफ डिजिट्स दे देगा इनसाइड द नंबर n. तो फिर ये फर्स्ट वैल्यू. सेकंड, while n is greater than 0, last digit ये एक आंसर इक्वल टू मैथ डॉट पावर ऑफ प्लस मैथ डॉट पावर ऑफ द last digit comma last digit comma what is the digit, last digit comma digit, bracket is closed. So answer is equal to math dot power of the last digit comma digit, bracket closed. It is a counting, removing the last digit. So n equal to n divided by 10. While n is greater than, if uh, अगर रिटर्न आंसर इक्वल टू एन, तो उसको स्टोर एन इनटू एनी वेरिएबल, फॉर एग्जांपल ए. तो इफ आंसर इक्वल टू ए, देन रिटर्न ट्रू, और अदरवाइज रिटर्न फॉल्स. तो दैट्स नॉट अ आर्मस्ट्रांग नंबर. फिर इसके बाद प्रिंट ऑल डिवाइजर. फॉर दिस दे हैव टू अप्रोच, फॉर three approach. For initial approach, we divisor. So for int equal to I to n, if and the modulo I equal to 0, then array list dot add the divisor and close, and at the last return array list I plus plus. So uh, first this way. Second, second is the optimal solution. What? For int I equal to 1 to math dot sqrt of n. Yeah, I is less than I into I is less than n into n. So what we do, what we do, uh, take, if n modulo I equal to 0, then arraylist dot add I, or inside the if statement, if n modulo I is not equal to I, if n modulo I is not equal to I, then list dot add what, n divided by I, and after that we close if statement and outer if statement and return the array list. It is a printing the all divisor of the array, of divisor of number. ठीक. Check for a prime. How to check for the prime number? They have only two divisor. So count the number of divisor. If number of divisor is greater than 0 or greater than 2, then if number of divisor is greater than 0, then it is not a prime number, else it is a prime number. Okay? Happy number. Happy number, what is happy number? Happy number are taking each digit and square it and add it, then we get a doing continuously, we at the last we get a we get number. Okay? So firstly, for it, we write the square function. How to write the square function? Square of taking as parameter, and what he do, taking parameter as, and he take out the last digit and square it and store in the answer. So square function is the integer type. So int square is, and taking out the last digit, while n is greater than 0, uh, uh, mat answer equal to answer plus equal to mat comma mat dot pow power uh, last digit comma 2, or n divided by 10, n equal to n divided by 10, at the last return the answer. So this function is giving the answer, square of any number, square of any digit, square of digit, and adding it. Take. So what we do in the what we done, find the square. So we create two variable. First one is the slow and second one is the fast. Slow is initialized the square of n, fast is initialized by the square and square of n, both time square, while square is not, slow is not equal to fast. So slow is equal to slow equal to square of slow, or fast equal to square or square of the fast. It is in the case of the slow and fast. If when slow equal to fast, then it will be stop. When slow equal to fast, then it is stop. So return if slow equal to 1, then it is written true, otherwise it written the false. So for this way we check the happy number. Okay. The next one is binary to decimal. For binary to decimal, we get from the last value and multiply the with to the power. So creating the integer I, which is and taking out, while n is greater than 0, taking out its last digit equal to n modulo 10, we get a last digit. We initialize I equal to 0. So decimal equal to last digit into to the power mat dot pow to the power I, and to the power I, and close. This is adding the answer, and n equal to n divided by 10. It is a from and last return decimal value. So it is the answer divisibility by the uh, 10, and in binary to decimal. And next is a decimal to binary. For decimal to binary, we find the remainder. So while n is greater than 0, it may be n is greater than 0, and equal to n modulo 2, find the remainder. If remainder is can add it first. So remainder into answer equal to remainder into here also taking the variable I, remainder into 10 to the power I, 10 to the power I, 10 to the power I, or added to the binary number, add 10 to the power I added to in the binary number, and close remainder into adding 10 to the power of I, and close bracket. Uh, After that, removing remove the number n equal to n divided by 2. N equal to n divided by 2, we get a number. That previous one, what we do, last digit into mat dot power of the to the power I, and here remainder into mat dot power of 10 to the power I. This way we find the decimal to binary conversion. फिर math.ceil will get if integer upon integer, then math.ceil get the which starting number. If double upon double, then math.ceil give the next number. Okay. And third one is from character to number. For example, if the character is 1 and we want a number, so divided by character by 0, subtract by character 0.